ગુડ મોર્નિંગ સ્ટુડન્ટ્સ. કેમિકલ થર્મોડાયનેમિક્સની અંદર આપણે જોયું હતું વેરિયસ રિલેશનશિપ બિટવીન પ્રોપર્ટીઝ. ઓકે, then after we discuss Celsius and Clapeyron equation. Now હવે જે રિલેશનશિપ છે એ શું છે? ડિફરન્ટિયલ ઇક્વેશન ફોર એન્ટ્રોપી માટે ડિફરન્ટિયલ ઇક્વેશન, બરાબર. So how can we partial derivatives of entropy equation? Okay, so first, differential equation for entropy. The state of pure homogeneous fluid, the state of pure homogeneous fluid is uniquely determined by specifying any two thermodynamics property. કોઈ પણ pure homogeneous function હોય, homogeneous that means all these reactants are present in a single stage, in a same stage. So for that particular part, this any two thermodynamics property then can be determined by the homogeneous state of function. Choosing the temperature and pressure are variables. Other property like entropy are related to them, as S is the function of P and T. So the total differential of S is entropy. તો એ કોઈ પણ બે ફંક્શન છે, બરાબર, એના સાથે જેમ કે એન્ટ્રોપી છે, it is a function of pressure and temperature. So how it can be defined that for a constant temperature and constant pressure, so it can be written as a ds del s by del p at constant t into dp plus del f del s by del t at constant p into dp. Okay, now the next value or equation is that putting the values, substituting the equation 6.24 and substituting the equation 6.24 and 6.31 into the above. So 6.24 is said that the equation 6.24. So 6.24 is said that del t by, हमने पढ़ा था कि del t by del v at constant s. तो उसके लिए हम क्या कर सकते हैं, इसको हमें पुट करना है 6.31 के अंदर. तो 6.31 ये क्या है? 6.31 is that del s by del t at constant p. ओके, तो del s by del p, तो वो कहाँ से आया? del p by del s which is from the कंपेरिजन ऑफ एक्टिविटीज, वहाँ से ये फॉर्मूला हमें मिला है. ठीक है, तो उसकी जगह पे हमें क्या कंसिडर करना है? Cp by T del S by del T. Okay, Cp by T. So put that Cp by T and del S by del T P की जगह पे हम क्या पुट करेंगे? del V by del P at dp. Okay, del V by del T by dp. So the next equation is like that. Okay, अब वो equation किसा हो जाएगा? ये इस तरह से. Now entropy were treat as a function of temperature and volume. entropy को कैसा ट्रीट किया जाता है? in this particular function के लिए it is a function of pressure and temperature. Okay, So right now we consider as a function of temperature and volume. So what should be done here? The del S is equal to del S by del V plus dV plus del S by del T at dt, constant temperature and volume processes. Similarly, as per we do in above, substituting the values of equation 6.23 and 6.32 into 6.36, तो 6.23 के हिसाब से हमें क्या पुट करना है? हमें जो प्रॉपर्टीज है 6.23, डेल पी बाई डेल टी एट वी इज इक्वल टू डेल एस बाई डेल वी एट टी, ठीक है, उसको रिप्रेजेंट करना है। और उसकी जगह पे हमें क्या पुट करना है? 6.32 की वैल्यू, इट इज सी वी बाई टी, उसकी वैल्यू क्या है? सी वी बाई टी है, ओके। प्लस यहाँ पे क्या आ जाएगा? डेल पी बाय डेल टी एट वी, okay. So these are the relation. Now the partial derivatives of del p by del t at constant v, derivatives of del p by del t, ये टर्म की बात कर रहे हैं, in the equation 6.37 can be expressed in the terms of del v by del t at p, okay. આ રીતે જે રીતે રિપ્રેઝન્ટ કરી શકીએ એ રીતે આપણે આ રીતે પણ શું કરી શકીએ છીએ? એક્સપ્રેસ કરી શકીએ છીએ. આગળનું ઇક્વેશન 6.35 છે એ પ્રમાણે. And del v by del p at a t, del v by del t at a p in terms of uh, uh, and which in terms are related to coefficient of volume expansion and compressibility of the substance respectively, okay. Now how it can be done through right here? So it can be done. First, let the volume be expressed as a function of p and t. So volume is the function of p and t. Then the total differential volume where v can be written as a above, जैसे ds लिखा था अभी उस तरह से dv लिखना है, प्रेशर एंड टेम्परेचर को फंक्शन को. So it can be written as a dv is equal to del v by del p at t at dp और del v by del t dt at constant p, ठीक है. एट अ कांस्टेंट वॉल्यूम अगर होगा तो प्रेशर क्या हो जाएगा? सॉरी, वॉल्यूम क्या हो जाएगा? जीरो, क्योंकि वॉल्यूम क्या कर दिया है हमने? कांस्टेंट. सो कांस्टेंट वॉल्यूम dv इज इक्वल टू जीरो. सो अबव इक्वेशन कैन बी रिटन एज dv की जगह पे क्या पुट करना है हमें? जीरो. तो लेफ्ट हैंड साइड हम dv की जगह पे हम पुट करेंगे जीरो. तो ये क्या हो जाएगा? जीरो इक्वल टू ये पूरा टर्म. तो दैट मीन्स डेल वी बाई डेल पी एट टी डी पी इक्वल टू जो दूसरा टर्म है वो क्या हो जाएगा? ऑटोमेटिकली दिस वन इज अ नेगेटिव टर्म, ओके. सो दिस वन इज अ नेगेटिव टर्म एंड दिस वन इज अ कांस्टेंट वैल्यू, ओके. ये जो वैल्यू है वो क्या होगी? कांस्टेंट. एंड रीअरेंज दिस इक्वेशन, ओके. इस इक्वेशन रीअरेंज करते हैं तो क्या हो जाएगा? del p by del v, del p by del t is equal to minus del v by del t at a p and dv by del p at a t, which is equal to the minus del v by del t at a constant pressure and pressure del p by del v at a constant temperature, okay. Now when 6.38 is substituted into 6.37, अगर 6.38 ने 6.37 में આપણે add करिए तो substitute करिए तो we get the differential equation for entropy as a below. तो del p by del t की वैल्यू हमें कहाँ पुट करनी है? इस इक्वेशन की वैल्यू हमें पुट करनी है 6.37 के अंदर यहाँ पे, ठीक है. तो वो क्या हो जाएगा? डेल एस इज इक्वल टू सी वी बाई टी डी टी माइनस डेल वी बाई डेल टी and divide by del V by del P into T dV. Okay, so this equation is differential equation. And finally we got the relation between entropy and other properties. So these are the ds is equal to Cv by T dt, and minus this pressure minus the equation number 3 6.30, and that is del V by del T at P divided by del V by del P at T, where differential constant is dV. now Now let me do the relation between Cp and Cv, specific uh, Cp and Cv. Okay, so derivatives of Cv and dV. Uh, how can we write? So relationship between Cp and Cv is given by this equation, which have seen that the partial derivatives of entropy with respect to temperature and that are related to specific heat. So this equation we already discussing in equation 6.31, which is the relationship between the entropy and temperature, and then entropy and volume. So from equation number 6.31 and 6.32, so it gives us a del S by del T by at a constant pressure. Uh, it having a value is Cp by T, and entropy del S by del T at constant volume, it is a Cv by T. Okay, this relation we already known that. Also we discussed in previous sections. So from the equation number 6.35, okay, previous, the differential form of S is that, so del S is equal to Cp by T, and here dt is multiplied here over here, okay, minus del V by del P into dP, similar to this. So dividing the equation by dt and imposing the constant volume a restriction above equation, and it can be becomes डिवाइड करना है, किससे करना है, dt से. So यहाँ पर dt will be cancel. Okay, so remaining only ds by dt at v. Okay, both hand side we have to multiply and divide. So ds by dt at constant v, this dt will be cancelled, and remaining term, so here dv by dt is already at a constant v, then dp यहाँ पे क्या आ जाएगा, next term is which is divided by dp. Okay, so which is here at constant v. So substituting the equation 6.32, 6.32 is relation which is relation of the pressure. So put into the 6.52. Okay, so from the equation number 6.52 we got Cp by T. So here exactly Cv by T. Okay, and equation this one is Cp by T minus uh, other term is as it is, only del S और del T by V की वैल्यू हमें पुट करनी है, तो इसकी जगह पे क्या हो जाएगा, Cv by T. Okay, now if we rearrange these equations, so Cp minus Cv, Cp को इक्वल टू को इस साइड लेते हैं, तो Cp minus Cv इक्वल टू T को, T तो कॉमन है तो कॉमन एंड कैंसिल, एंड देन मल्टीप्लाइड विथ हियर ओवर हियर. सो उसको हम मल्टीप्लाइड यहाँ से करेंगे तो क्या हो जाएगा, Cp minus Cv is equal to T as it is other equations. So now the relation is getting this like this. This equation can be used to replace del P by del V, del P by del T at a V, constant V from these equations. इसके अंदर जो can be used replaced by del P by del T, એટલે કે આ જ equation છે એને replace અને rearrange કરીને લખવાનું છે. So their equation is can be written as a Cp minus Cv is equal to minus T del V square by del T at P del P by del V at a T. Okay, and the from the PVT behavior, okay, from the PVT behavior, the fluid is known either as an equation of state or a graphical result. So this equation is used to evaluate difference between Cp and Cv wide ranges of temperature and pressure. As equation છે, this equation can be used for the wide ranges of the values of Cp and Cv with temperature and pressure. Equation 654 can be written in terms of coefficient of volume expansion beta and compressibility k. So this can be written as a beta is equal to 1 upon v del v by del t eta p, and k is equal to minus 1 upon v del v by del t. Okay, and let here do del v by del t p is considered as a beta and del v by del t is considered as a k. So right, both values are put into equation number 54. So we got a new equation which is Cp minus Cv is equal to beta square Vt upon k. Okay, and this equation is a most convenient equation from the calculation of Cv and Cv for the liquids and solid. Okay,